Okay, the next machine you'll need is a sandblaster, and that's a very inexpensive but very useful tool, because if you want to bond things with adhesives or if you want to paint things, the only way to guarantee a really good bond is to sandblast the surface. We'll talk a little bit more about it when we talk about painting. So these are very simple devices. The only modification I recommend doing is replacing the window with a diamond-coated window, like I did here, because the problem with sandblasters, the way they are made, they have a glass window and a protective plastic, because a grit will cut the glass right away, and the protective plastic is replaced every few days because it gets hazy from the grit, or opaque. So it's a lot of maintenance to constantly replace the protective plastic. Now you can buy these glass panels which are diamond coated, and they're used for supermarket scanner checkouts, so they don't scratch from the product, and they cost about maybe $20 each, but they last a lifetime. So I had this here for many years, and they are as good as new. And it's important to be able to see when you sandblast what you're doing to make sure everything is cleaned up. So the operation is self-evident. You put it inside. Hold it up here. Okay. That's it. This one has a vacuum, which is a good thing, so when you open it there's no dust inside. And also you can see better. So you can see the effect where it was sandblasted. Okay, so this is a painting and welding area, but before we get into painting, let's talk a little bit about surface preparation. So the paint or adhesive sticks to the metal by a combination of a mechanical and chemical effect. So mechanically, if there is roughness on the surface, it locks in mechanically, but a lot of the bonding comes from a chemical effect, some of it through the surface energy, which is released of the surface, some of it through true chemical bonding, like for example when you bond glass with silicone rubber adhesives and so on, in some adhesive you form a true bond and get a tenacious bond. So we'll talk separately about bonding, so let's just talk about painting. So there is the classical way which they talk in books about preparing a surface for painting is completely useless, because all the books say clean it with a solvent or rub it with sandpaper, and the reason why it's useless is if you clean something with a solvent, no matter how much you wash it with a solvent, you're just diluting the hydrocarbons or the oils. So at the end, there is always a monolayer left, because a monolayer is one molecular layer of hydrocarbons, and this is enough to prevent a chemical bond. And if the surface is very smooth and there is no chemical bond, say, the paint will not hold. The standard test for paint adhesion is a tape peel-off test, and the way it's done, you have to find a very strong tape, like the strongest duct tape you can find. You take the painted sample and you do a crisscross with a knife. Maybe 4 by 4 squares. You put the tape on and peel it off, and if there is any piece of paint lifted, it failed. Okay? Now this tape isn't that strong and this paint is not bad, so this surface was not prepared, but it's still borderline, because for example if you bend it a bit and then you repeat the test, see, it looked okay, but it's actually not a very good paint job, because if I bend it a bit and I repeat the peel-off test, now it looks bad. Okay, so what it means, it's not a real bond. Okay, so if I do the same test, which actually I done here, so this has already scratches in it, and I can bend it, Okay, and then I can do the same test as many times as I want, nothing will come off. Okay, so basically if you want a really good paint job, it has to be able to pass the peel-off test, and especially the peel-off test after you bend it once or twice. Okay, now so if you just take the material, clean it and wash it, even sand it, sanding is better, but washing with solvent is pretty useless because it still leaves a monolayer. So there is only two good ways to prepare. There's actually three good ways to prepare the surface. The absolutely best is sandblasting, and that you should always do that if you can. Now sometimes you can't, and the two cases where you can't is A, the object is too big, it just doesn't fit in the sandblaster, like you have a car to paint. Okay. The second reason you can't, if the sheet metal is very, very thin. Because if any metal thinner than say 0.5 millimeter, if you sandblast, will completely distort. Now the reason is the sandblasting will put in, it's like shot peening. It will put in compressive strength in one side and the piece will immediately bend. If you flip it over and sandblast the other side, it will straighten out, but never perfect. So if something is made of very thin material, you cannot sandblast it without distorting it. So the next best thing to sandblasting is either bluing it. Bluing it is heating it to about 300 degrees Celsius, or scrubbing it with these bathroom cleaners like Ajax or Comet. And the reason is that these bathroom cleaners activate the surface. They not only remove the oil, they actually activate the surface because they also oxidize and they activate the surface. So the test to know if a surface is ready for bonding or painting is called a wetting test. So I'll show you the effect. If I take a piece of metal and if I put a drop of water on it, the water will bead. Okay, that's just plain water. The water will bead up. So here you can see the water drops, not spreading but beading. Okay, if I do the same where I sandblasted, when the water wets. So here the drops just roll off, here they leave a completely wetted trace. Or another way of doing it, if I put the water and spread it with my finger here, and I tilt it, the water just falls off like from a duck. If I do the same thing here and spread it with my finger, the whole surface becomes wet and the water doesn't fall off, it just spreads. Now the angle between the edge of the drop of water and the surface is called contact angle, and that is direct measurement of the surface energy. Because if the surface energy is high, it will overcome the surface tension of the water and pull the water and spread it. If the surface energy is low, it will actually not open the water at all and actually repel the water, say if it's hydrophobic. So if you don't get this wetting, you are wasting your time trying to glue it or paint it. Okay, so we showed you, so the first way to get the wetting is sandblasting. Now the second way to get the wetting, which is not as effective as sandblasting but sometimes simpler to do, is heat everything to about 250 to 300 C, and that's easy if you have a big oven for painting, which you need anyway. So you put it in the oven before painting, heat it up, spray paint it with a powder as we'll see, and put it back to the oven to cure. So the equipment is there anyway, you may as well heat it up. The big advantage of heating up an object before painting is that anything which can give you bubbles or defects in paint will disappear in the first round of heating. Let's say I have a piece which is welded and drilled and there is some moisture trapped or there is some cutting oil trapped in it. If I powder coat it, bake it, this cutting oil will bubble out and make defects on the paint. But if I heated it up anyway once before painting, everything which is volatile came out already, so the paint job is more likely to be perfect. So you can do both. You can actually sandblast and heat up. Okay? Now if you heat up steel, it's very easy because the steel changes color, so you know exactly by the color the temperature. So you usually do it in an oven, but I'll just do it here quickly. So you can see the color change. Okay. Don't heat it up more than 300 because we don't want it to oxidize and flake off. We just want a very, very thin layer of oxide which is adherent. You can see here the water beads and falls off, here it wets and stays. Okay? Now the third method of preparation is scrub it, as I said, with something like Ajax or Comet. I know it looks like a Comet commercial, but you basically take any one of these bathroom cleaners, the powder ones, you scrub it and rinse it off. Then I do a wetting test. Again, I get very good wetting. I don't know if you can see it in the picture, but the water spreads completely, okay, because it activates the surface. Now as a comparison, if I do the standard textbook solution and I take a solvent, okay, so say if I take acetone and I clean it with acetone and I do the wetting test, let it dry. The wetting test, it does nothing. There's no wetting. Okay? So the difference is that this just dilutes the hydrocarbons but still leaves a monolayer, while the Ajax or the Comet or these things decompose them at the end, just like soap does, and emulsifies or decomposes them, oxidizes the residue or whatever chemistry takes place, and leaves a surface with high surface energy. Now, a very important thing to understand that all these effects, the wetting effect, disappear in about an hour. So if I come back to this piece next day, none of these will wet. And the reason is the air is full of hydrocarbons, and by adsorption, the hydrocarbon molecules will recoat the item. So everything has to be painted within 1 hour of activating the surface. The same for glue bonding or any operation, surface operation, plating. If you nickel plate, if any operation to do with surface bonding has to be done within 1 hour of activating the surface. Now there's a way to protect the surface, it's called gumming. If you have to clean a lot of parts one day and paint them the next day, there is a solution called gumming solution. You can wash the parts in and rinse them off next day, and it preserves the surface activation, but it's not for prototypes, you just clean it before use. For example, this piece that I did the test on was blued and sandblasted yesterday. And I suspect that if I do the test here, on the blued part, yeah, you see it lost any ability to retain the water. The water beats off, and if I spread it, it doesn't stay. So while yesterday it worked perfect, as the test shows, and even the sandblasted surface, it's better. Sandblasted surface retained most of the quality, but not quite. See, the water doesn't fully coat it. So this retained about half of the magic, and this lost all the magic in one day. Surface energy is a product of the specific surface energy and the surface area. So you can have something with a low specific surface energy but has a highly structured surface, so the total surface area is very large, because what matters is a product. So you can even take Teflon, which is hydrophobic as hell, and you can make it hydrophilic by texturing the surface enough that there is so much surface area that when multiplied by a low specific surface energy still gives a big number. So that's the trick. So the trick is why this retains more is simply because what matters is a product of the area, and this has much more areas than this. That's what does it. It's not the mechanical anchoring, it's just the fact that the area is so much bigger. So after you prepared the surface, you electrostatically paint it, and the best thing to do is, the reason why I suggest electrostatic painting is because it's done with powder, so there is no cleanup issues. Because if you paint it with wet paint, which works fine, there is cleanup of wet paint, which is a problem. So what you need is to hang it from a grounded surface. So if I wanted to paint, say, this piece, okay, let's paint this piece, I have to usually when you make the part on the water jet, if it has no holes, you make sure you leave one hole just to hang it. Okay, like this. Now, take all this away. Take all this away. Now, these systems are very, very cheap now. You can buy a system now with variable voltage for powder coating for $500 or less, and you can buy a system without variable voltage for less than $100. It's very, very cheap. A good supplier for all these things is a company called Columbia Coatings. They have a website, they have a zillion colors, courtesy of all the custom motorcycle manufacturers, so they have every color on earth. So what I do is I buy many of the cheap guns and keep each gun for one color, so you never waste time flushing out the guns. Okay, this works on low air pressure, like 10 psi. Now if you don't use electrostatics, the powder goes everywhere. So if I push, you'll see the powder go everywhere, not necessarily to the workpiece. Okay, if I turn on the high voltage, this is ground, this is at minus 30 kilovolt, so the powder only goes to where it should. Okay, it's just attracted, and the amazing thing is, even if you spray just the front, the powder goes to the back too. Okay, not fully, but if it's a narrower piece, the powder will fully cover the back because it goes around. The powder which misses it is pulled back. So even if I shoot here, not at the object, the powder will be pulled back and cover the object. So that's a very, very good way of painting. Provides many, many colors. So one of the more interesting paints you can buy is a chrome paint, which looks just like chrome plating, and it's quite durable. So you paint it, and when you paint it, it doesn't look like much, but then when you put it in the oven, it turns into a chrome finish. So just to do it fast, I wouldn't put it in the oven, I'll just heat it up a bit like this. So this is a chrome paint powder, but as soon as you heat it up to the right temperature, it fuses and turns like a chrome finish. And if you look at it, it gives you a beautiful effect of chrome plating, and it's quite durable. So this is just a quick note on how to fix defects before painting. Sometimes you make a sheet metal enclosure and you got some dents in the sheet metal. Especially you get a lot of defects when you have to weld a larger enclosure and you sand off, but you still have some dents left over from the welding you cannot sand out. So the textbook solution is you buy a special high temperature patching compound which can tolerate the baking temperature of the paint, but it doesn't work very well, A, because it's weak, B, because it discolors the paint. And so altogether a much better solution is use the paint itself to fill defects. So what you do is you heat up the part to about 230 degrees C, the same temperature as for painting, and while the part is hot, you just sprinkle some powder from the same powder you use for painting into the defects. The paint will melt and fill the defects. So let's do that. So I have two boxes here which had to be welded. So what we'll do Actually, we put them on an insulator so they stay hot longer. And close the oven. So I sandblasted it before, and now all what I do is I take some of the same powder, the paint powder, and wherever there is a dent, I put in powder. It doesn't have to be accurate because I'm going to sand off the excess anyway. Okay, so the powder melts, okay, and just beautifully becomes solid epoxy or whatever it is, polyester, and fills all the dents. Okay, it's already melted. Now we do the same. The powder not only melts but cures. Within a minute it will become rigid. Okay. Check if it's all filled. Yeah. And when we finish, we can just sand it flat. Okay, so now we let the melted powder cure for about a minute or two, and then we let the whole thing cool down. Now once it cooled down, we just sand it and all the defects will be filled out. So now what you can see is the white powder which it melted only stayed where there were dents. Okay, obviously you're going to do it with the same powder you're going to coat it with, because this way you guarantee there will be no color show through.